Hello, my name is Gunnar Grün and I'm the Deputy Director of the Fraunhofer Institute for Building Physics IBP and Professor for Building Physics at the University of Stuttgart. I would like to welcome you to the first video of our module on the Lighthouse project in Chennai. This module, which introduces you to the precast concrete construction method, includes a total of 6 videos. Those videos address different construction challenges related to building physics in the context of the climatic conditions of Chennai, such as the heat and moisture transport mechanisms, the energy efficiency, the durability and the thermal comfort. In the last video, the research overview wraps up this module. But now let's zoom into our first unit. In the following, I give an overview of the construction itself. How is it built? How did the construction process look like, step by step? And what is the outcome? Also, at the end, I'll go into detail about the content of the next units in this first module. By this, you can already get an idea of what to expect. Now let's start. In this short video sequence, you see the Chennai Lighthouse project. 1,152 housing units are built with the technology of precast concrete construction. The structural system used for the construction in Chennai is a precast concrete system. The method of construction is a so-called 3S system. 3S stands for strength, safety and speed. The speed of constructing is quite high because there are many prefabricated parts and components. For example, the columns, the beams and also the reinforced concrete slab in hollow form are prefabricated at the construction site of nearby. That way, these components can be put together quickly in the actual construction process like a puzzle. Prefabrication not only increases the speed of construction on the building site, it also improves the quality of the component, since the process can be constantly monitored and the production is decoupled from the effects of weather. Furthermore, the overall costs can be reduced. The material properties of the concrete mix are decisive for the later evaluation of this construction in terms of energy efficiency, comfort and also durability. The strength of the system is provided by filling of the components in situ with reinforced concrete. These wet joints create a monolithic structure which ultimately adds up to the overall load-bearing system. In this skeleton structure, the walls are filled with so-called AAC bricks. Unlike conventional bricks, these are very light, reducing the load on the concrete structure itself. They also have larger dimensions, so fewer blocks are needed. And the material of AAC bricks has a very low thermal conductivity. In consequence, there is a good insulation between the external and the internal temperature. Since you are now equipped with a basic knowledge of the structural system, we will continue with this construction process of the Lighthouse project in Chennai. The overall structure in Chennai consists of the substructure and a superstructure. Here you can see that this substructure was executed as a conventional foundation. There are the base foundations and also some concrete areas in which the columns for the basement are then filled at the same time. In the lower part you can see the production of some prefabricated parts, partly directly on the construction site. As already discussed, the skeleton structure of the entire building is then assembled from these in the next step. The procedure then continues with the superstructure on top of the foundation. First, the concrete elements are placed, as we have already seen with the columns. Then these columns and beams are joined together with the help of wet joints so that they are firmly connected to each other, forming a monolithic structure. For each floor, the ceiling slab or floor slab is placed and also filled and connected with the concrete. Finally, as the last step, the walls are erected in the still open framework structure with the already mentioned AAC blocks, i.e. the aerated concrete blocks. In this short video you will see exactly what was just explained. From pouring the foundation and creating the precast concrete elements to assembling the individual elements. Meanwhile, this lighthouse project is finished. This enables us to have a look at the building physics challenges based on this project. This is what your lighthouse project in Chennai looks like from the outside. And this is what the floor plan and apartments look like from the inside. Let us take a look at the building physics challenges we have with this construction and what we will discuss in the next units. I just want to pick out a few of them and give you a brief overview of what you are going to learn in the upcoming submodules. This module, as I mentioned earlier, consists of 6 videos in total, starting with the first, which gave you an overview of this Chennai project and how it was constructed. The next video in this module is about the heat and moisture transfer in building components. We will first look at what heat and moisture transport is in the first place. What are the potentials? How can we measure it? How can we calculate it? And what are the special requirements in Chennai regarding heat and moisture transport? With that background information, you can then watch the next unit from this module, where we'll look at how to improve the energy efficiency of the Chennai Lighthouse project. We'll look at how to balance the energy budget of the structure and how to improve it by, for example, insulating the surface or reducing the impact of thermal bridges. We will also look at how to optimize durability when using concrete and aerated concrete blocks in other units. For example, there could be a problem with moisture on this surface or moisture within the structure, which could lead to corrosion on the one hand, but also to mold growth on the other. Then, in the next video, we will talk about the comfort rating. If you know something about heat and moisture transfer, and if you know the energy efficiency measures, and how to evaluate it, how to balance it, then you can also go a step further and say what's happening in the structure, what's happening in the home, what are the temperatures, the moisture in the substructure, and what impact is on the people who live or work in the building. The last video will give you an overview of the research. We are going to have a look at the materials themselves. We look more in depth at potentials to further improve the construction that was built in Chennai. For example, by using different materials, by replacing the aerated concrete block material with a different type of concrete. The goal is that in the end you will have a pretty intensive overview of all the aspects, especially the building physics aspects, that can occur in this method of construction. And With deep insight into this method of construction, you can then have a look at the next module and its specifics. With that outlook, I would like to thank you for watching this opening lecture and looking forward to seeing you in the another one.